The chain rule states if g is differentiable at x and f is differentiable at g of x, then the composite function f equals f of g, defined by f of x equals f of g of x, is differentiable at x, and f prime is given by the product. There's two ways of stating that. F prime of x equals f prime of g of x times g prime of x, or using the Leibniz notation, if y equals f of u and u equals g of x are both differentiable functions, then dy dx equals dy du times du dx. Most of the time we're going to be using the first method. In this video we're going to be focusing on the Leibniz notation, making sure we can identify the composite function, the inner and outer parts. For example, identify u equals g of x and y equals f of u for f of g of x, and then find y prime. So we want to identify the inner part, which is u, and the outer part, which is y. So looking at this function, we can see that it is a composite function. 1 plus 4x is inside the cubed root function. So the inner part here is u equals g of x, or 1 plus 4x. The outer part is y equals f of u, or more specifically, the cubed root of u. So using Leibniz notation, again, dy dx equals dy du times du dx. We want to start with dy du, the derivative of y with respect to u. Notice that this is really the cubed root of u. We can rewrite that as u to the 1/3. Taking the derivative of this with respect to u will give us 1/3 u to the negative 2/3. And then we want to multiply by du dx, that is the derivative of u with respect to x. The derivative of u, 1 plus 4x, with respect to x is 4. So we're multiplying by 4. So simplifying this, we get 4 over 3 cubed root of u squared. And then we just need to replace what u is. We have 4 over 3 cubed root. U, we said earlier, is 1 plus 4x. And we have found y prime, or dy dx. In this example, again, we want to use the Leibniz notation, identifying the inner and outer parts to help us find the derivative. So the inner function, u equals g of x, in this case is pi x. Right? That's on the inside of the tangent function. The outer function, y equals f of u, in this case is tangent u. So again, Leibniz notation, dy dx, dy du times du dx. So the first one, dy du, that's the derivative of y with respect to u. The derivative of y with respect to u is secant squared u. And now we want to multiply by du dx, the derivative of u with respect to x. Here's u. The derivative of this with respect to x is simply pi. So we have pi times secant squared u. But we want to replace the u now. U, earlier we said u was defined to be pi x. And now we have y prime or dy dx.